So we are good to go. So for Project Olympus, we created a work group, and we invited one of the Microsoft partner, which is the AMI. Actually, we have done lots of joint effort development on the different hardware platform that currently are shipped to Microsoft data center, and so we ask AMI to join this effort. Actually, for OpenBMC, they have lots of server manageability expertise, and they can bring those experts in the community. So I invited Sanjoy from AMI to join the discussion on this presentation. So agenda for today, I'll give you a little bit background about the Microsoft adoption of OpenBMC, and also we'll discuss our roadmap for OpenBMC, the contribution to the OpenBMC, what we are going to do in future with unified OpenBMC. And then Sanjoy will give you some status update about running the OpenBMC on the Project Olympus. And at the end, we will discuss next step to enable OpenBMC on the Project Olympus. We just started this project a few weeks back, so it is just the beginning. And we expect to do lots of development effort to realize all the features that were required for server manageability. So for those people who are not familiar with the Project Olympus is actually a portfolio of the product that Microsoft contribute to the OCP. It's an umbrella. It includes different hardware platform, from the server platform, Intel, AMD, ARM, to a storage platform, to GPUs, rack infrastructure, rack manager, all is under one name as Project Olympus. So as for open hardware platform, the firmware is a key element of the enablement of that open hardware enablement. So and it, as our commitment, as Microsoft commitment to contribute to open hardware platform under OCP, we decided to put more focus on the open source firmware, actually, that can be shipped with those open hardware platform. So about 1.5 years ago, we did some research and investigation about the open source solution which was available out there, and we decided to adopt the OpenPower OpenBMC that was actually created originally by IBM. And we decided to try that OpenBMC, OpenPower OpenBMC, on some of the low volume platform that like the storage that we wanted to ship to the data center for the first time. And the reason that we plan to ship the OpenBMC on the low volume just as a risk mitigation. That was the first time we were exposed and experiencing this open source solution. We had to educate ourselves to understand what is the firmware architecture, and we also, for all the hardware development that Microsoft does, so we are interacting with lots of partners. And we had to educate them also to get up to speed and do the rest of development based on the OpenPower OpenBMC. So here in the block diagram, you can see the hardware manageability that we first tried.
Sorry to interrupt you. Could you put it in presentation mode so the details of the block diagram? It's too small.
Is it too small? Yeah, let me put it. Yep. Is it better? Welcome. So this is the block diagram, and here you can see, comparing to the server, those storage enclosure, we have the number of sensor or the number of interfaces that we have is much less. So here in this architecture, we have just a BMC. We have 4 satellite controller, or IO expander, which is the SAS expander that are connected to BMC over SMBus. And we have the PWM and the tachometers for the fan control and a bunch of other I2C sensor and GPIO-based discrete sensor, which are connected. So, and so far, we are able actually, so we had lots of challenges, as I said, to educate ourselves, to do some optimization, to fix some of the issue that we were seeing in the beginning. But at the end, we were able to ship the OpenBMC on 3 different hardware platforms. That was a great successful and great achievement for us. And we created a community that through working with these partners, ODMs, we created a community that now they know what is this firmware architecture and how we should do the development, what are the challenges, how it should be extended. And that was also a good achievement in addition to just shipping the firmware to the data center. So this is the block diagram of what we are shipping right now on those platforms. So we have the firmware update services. So we added the Redfish, just a storage profile. And we also added SMBus for satellite controller that is connected to the DBus. It grabs the sensor information from IO expander and it feed those information back to the sensor object, which is tied to the DBus. And we added the PM bus for the PSU monitoring. We added our own fan speed control that has two components, the algorithm and the fan tables. And we also extended the SOL SSH because each expander had its own UART interface, so we needed to extend that to support multiple UART interface connected to the BMC. And so we did some optimization to improve the response time. For example, you can see from the Redfish to the get event log. So we created a direct call from the Redfish, the event log, to allow us to get a quick snapshot of the event log when we have too many event logs stored. It improved the performance a lot. So this is what we are shipping right now, but what we are going to do as a part of OpenBMC on the Linux Foundation community, we want, as a next step, now we build up a good confidence about the stability of this OpenBMC. And the next big milestone for us is to enable OpenBMC on the server platform. And the first platform is actually Intel, Skylake. To do that, so we will leverage the work we have done so far. We will contribute this, the code that we are creating back to the community. And as I said, we have created a work group with AMI right now, but we expect other people, other companies who are interested in this effort join this discussion, this effort. We really need that to create a different perspective and to improve actually this firmware framework. So to realize that, we identify some of the features that we need to add. We need to add the IPMI over KCS and SSIF. All the Biospheres Interaction is based on IPMI in the Project Olympus servers. And also we have telemetry based on the in-band that use the IPMI. We also need to add the IPMB stack because we use the IPMB with the Intel manageability engine to get some of the sensor information of the platform, like the DIMM temperature, CPU temperature. And we use that, the PECU proxy also to access those information on manageability engine. And we also use the manageability engine for the power capping. So that's one of the requirements that we have in there. And we also need to add some more service that we're already using in the Project Olympus server, including the power capping. And we extensively use the remote media. Actually allows the host boots from the BMC. So we mount an image over Ethernet, and BMC expose that image to the host, and host can see that as a storage class device and can boot from that device. So we are going to add and work with the community to extend that feature. And we are already shipping the remote debugging. We had a work stream with Intel to do the remote debugging. I saw that Sai also mentioned that, that's great, that enable us to, right now for troubleshooting for some of the debugging the complicated feature, we had to send people to the data center. They hook up the ITP to get the memory dump, to look at the register. So we worked with Intel, and we added that feature to allow us remotely. Actually, it turns BMC into an IDP, but remotely over the cloud, you can connect to the node and do the debugging. So secure boots, that's one of the biggest gaps I think we have in general with the BMC, and our code goes under a strict security review by Microsoft security team, and that secure boot was one of the gap that was identified. And yesterday, by introduction of the Cerberus, this is a project that we are going to contribute back to OCP, so we can enable the secure boot. We need to do some firmware development effort on the BMC side to integrate the OpenBMC with the Cerberus. That works has already started, so it's ongoing. We were able, actually, a couple of weeks back, we were able to boot the OpenBMC while the Cerberus in the past. So we have made a good progress, and I expect that in next few months that integration got completed. So that would be a good addition to the OpenBMC stack, and will contribute all the design collateral and firmware back to the community, so other company can benefit from that. And the next thing that we need to think about that is the host tools. For the in-band, right now we use the in-band tools for telemetry. We use the in-band tool for the firmware update. And the current in-band tools, after some security review, there are some security gap in there. That's with IPMI tool. So we are thinking maybe we need to create, modify those tools, or we need to create something new that meet all the security requirement. Okay, with that said, as our roadmap, I think I asked my friend Sanjoy to join the discussion and give us a status update about how we are making progress with the OpenBMC.
Thank you, Ali. Hi, my name is Sanjoy. I'm coming from AMI. I work for AMI. Many of you probably know that company. We are mostly known for path to production. So OpenBMC is a very good initiative. We believe that a lot of innovations and community will be there. Some of the challenges that we faced, we have only 2 decades of providing production quality BMCs to all our customers. So with that experience, we believe there is a need for path to production, and some of the challenges that I would like to mention, and we would like to provide that from our experience and contribute to the community also at the same time. Of course, the first point goes to long-term supported. I think whoever is making product will definitely agree that taking a code base and delivering products for generations, like some of the customers sent and shipped their product for almost 10 years. And you have to go back to 10 years and support that code base and for their customers. So some kind of code management and all those things, and how we architect the code also for supporting for the long time. long term is important thing. So I think we are working on that, and we are very happy to work with Microsoft on this Project Olympus, and that's what we are putting on the Project Olympus project. Of course, the production worthy stack is the most important thing. So in this branch, we believe that it would be in the community, and it should be going through a lot of tests, QAs, and bug fixing, and should be reviewed and put in a proper way. Security and these advisories are very important for shipping a product. We believe that in the community, in the Linux community, as well as in the open software foundations, always we find the security advisors and the bulletins. That's not the problem. Problem is how do we implement and deliver to all the customers who are delivering the product. So there has to be a mechanism to do that, and that's our experience that we have found so far. So these are the things that we would like to contribute running these tests that from our experience, and then we can really contribute to the OpenBMC also at the same time. These are some of the challenges that we would like to point out. And we have a commitment. Our commitment to the OpenBMC and OCP is, of course, contribute to the Linux Foundation OpenBMC public tree. And at the same time, we have to come up with, we believe that some kind of long-term support model for the tree. So the companies who are making products can safely deliver the product for generations. And all the contributions should go there, and as well as available. The tool chain and everything, Ali has already mentioned, there are a lot of activities going on for building as well as for flashing and host-based tools. Those will be community-driven. Our contributions mostly start with the platform enablement. As I mentioned, that we are always path to production. We take these things and deliver to our customers such a way that they can make a product out of it. So one of the first platform enablements happened, of course, jointly working with Microsoft, and this is the example of Project Olympus. That is the development that we did and contributed. And from the core contribution point of view, we have planned to contribute multiple BMC hardware support, that kind of thing. Right now, speed 2500 is supported, and other BMCs are coming into the picture, so that is also an area that we can contribute to that. Of course, KVM, vMedia, we will also try to contribute there. We are doing that for many, many years. And security, not so much of really knowledge about the security thing, but most likely they're taking the security and vulnerability advisories and trickle to the product itself, and so anybody can support it. So what we did for Project Olympus is our contributions are mostly, we added KCS interface and for the BIOS to interface, and that's up and running today on Olympus platform. We added the IPMI based serial over LAN also, so it can be invoked by the IPMI tool as if like other BMC. There are I2C over LAN, which is the bridging mechanism that the IPMI tool can talk to any sensors over LAN. And of course, the IPMI LAN interface that we have added for this project because it's needed in some kind of applications. We did some chassis power usage, not a full-fledged power capping or anything that is in the roadmap that Dali mentioned. And we did some platform sensor support also available for this Project Olympus. These are the sensors that we have added. And we have added quite a bit of IPMI commands for both KCS and LAN, and this is the set of commands that is available today. So I would say these are all straightforward things. And next step is, of course, the GitHub is available to download this Project Olympus code base. Please try and join in this community. And I will turn over this to Ali to conclude our presentation.
Thank you, Sanjay. I appreciate it. So as a next step, as Sanjay mentioned, so we put this code, the source tree, under a GitHub. The next step, we want to follow the code review process with the OpenBMC on the Linux Foundation, and we'll merge this code back and contribute. But the code is available there. If somebody interested, you can go take a look, you can download, you can build it. If you have access to Project Olympus Intel platform, you can give it a try and can provide the feedback. But moving forward, we are also part of the Redfish work group under OpenBMC, and working together, I believe it creates a good momentum to achieve the goals, to achieve all these feature development. And we need different perspective. We need to talk to each other and make sure what we are laying down, it is robust enough. It is security hardened. So far, in last few weeks, there has been lots of challenges during those discussions in the Redfish work group. It's a weekly meeting, and again, I invite each of you to attend if you're interested. But there is lots of lessons learned, right? There is 4 different implementation out there, and each of us are defending our implementation. But that's good. That's created a different perspective. We are reviewing the different aspects from the performance, from security, how it can be extended. We need all those discussions. And I expect at the end, we might come up with not with single Redfish implementation. It might be 2, it might be 3. It's up to user how to pick. But at least we would know that what is the pros and cons with each implementation. So we expect to create the same momentum with the Project Olympus OpenBMC, that again, because we need to make some architectural decision moving forward. So Biospheres Interaction, there is lots of data is exchanged between the Biospheres. Some of those are persistent, how we are going to expose data, how we should tie those data to DBus, or we should redirect those data directly to the flash. So those are the architecture, the decision that we need to talk to each other, come up with a good, robust solution, and move forward. The other challenges we have seen so far is joint effort development. So accessing to the hardware platform is the big challenge. So we started this effort a few weeks back, but the biggest challenge was just enable AMI access to the Project Olympus hardware. Shipping those hardware, there are different teams geographically, I think, on different locations. So it took lots of time and effort. So we need to think about that. We have a weekly discussion. That's the technical steering committee of the OpenBMC. We are discussing this. We are thinking about that, and we welcome all the feedback about how we can deal with all those challenges. Okay, that's it. If there is any question.
Great question. So with your long-term support fork that you'll have, with your long-term support, you mentioned about doing security updates for patches and CVEs. You can do that for your long-term support branch. How are you planning on pushing that up into the OpenBMC project, and how soon? So that we can all benefit from those patches.
Yeah, that's the thing. So probably in what we have done so far, we can go ahead and merge these, so everybody can have access to that. But we need to have more discussion, actually. So when we should start merging, we should complete a feature, we should complete the platform and then merge, or we should do it on the fly. So those are the discussions we can have with the community. But for this specific bond, because the platform is up and running, is not full feature, there might be some bugs, but we are going to contribute this back in near future.
Yeah, I'm more concerned about the CVEs and security patches that would be fixed, not necessarily the features, if they still apply.
Yep. So what should be the model for the long-term support? That needs to be discussed, to be honest. So we want, what does it mean, the long-term support? We should create a different branch, or we should create a bunch of Yocto recipe that actually represent that long-term support. Those are the discussions we should have at the community level and take the best approach. We don't have any clear answer to that.
Just the starting
Thank you.
point.
Anything else? Yes.
Is there anything from the AMI BMC code base that you are not going to release?
No, whatever is OpenBMC and whatever the platform will be supported will be all open source.
No, I mean, AMI already has a proprietary BMC code base. And I'm
Yeah.
asking you about that code base. Are you going to open source that?
Right now, there is no decision on that at all because that code base also has a lot of IPs, not only from AMI, but shared IP. Because as I mentioned that we are supporting our customers for last 20 years. And there are tremendous amount of shared IP also developed. We cannot just go ahead and open source. So these are all Apache 2 license, fresh code, and our contribution. So we cannot mix these things at all. So we have not decided or thought about the other path yet.
But so there's nothing stopping you from doing the stuff that you think is not under some other license? Like some of these interfaces that are currently missing from this BMC, the video, the KVM, mounting remote media, that kind of stuff.
Those will be all added Apache 2 license separate code. We cannot bring that code to these licenses because of our customer relationship.
Any more questions?
Sorry, I'm not incredibly familiar with AMI. I don't quite understand. I know AMI has their own proprietary stack, and then there's this one that you've called AMI OpenBMC. What is the relationship, if any?
AMI OpenBMC. Project Olympus OpenBMC.
It says AMI OpenBMC.
Yeah, that's I think temporary. We're staging the firmware upload. So they try to merge the code, but this is not the thing they can do in a couple of days. We just fix a few bugs.
Because
so we said, okay,
review
let's make it
process.
let's enable access. So they put it in a temporary GitHub, but after that we'll do.
Oh, so it was for AMI to use.
Yeah, that's for the development purpose.
But the intention is to eventually merge that.
Absolutely.
Yeah.
Foundation
Yeah.
BMC project.
Two merge is going to happen. One, what the Microsoft has done with OpenBMC. It include the Redfish storage profile, the dual flash update. What else we have done? The SMBus, PMBus. We are going to contribute that to the Linux Foundation OpenBMC. And this one, the Project Olympus for Intel Server, will contribute it back. But one of the things that we should be aware of that, I think that's a key to the success of OpenBMC in future, that we need to align the efforts, right? We need to work together because duplicate effort to, for example, to enable the cases, and it would be a waste of time. And we are losing the bandwidth actually to get OpenBMC up to speed on the server platform. So my perspective is that we should work together and make sure what we are doing. And communication is also key, the communication to the rest of community, what we are doing. So the work group, I think each work group has a leader, actually, that one of the responsibility and role for that leader can be just communicate the activities, the discussion is happening in that work group back to the community, make sure we are all on the same page.
Okay, thanks guys, appreciate it.
Thank you.
Yeah.
Good to see you again.
Nice to see you again. Yeah.